se saca seda muy fina. Los chicos le dan al torno y la chica los anima. Los chicos le dan al torno y la chica los anima. Ya no hay comida pa'l pillo, el moral se me secó. María la tengo triste, el bicho se me murió. El bicho se me murió. El bicho se me murió. Ya no hay comida pa'l bicho, el moral se me secó. Hilando, hilando, el hilo rompió. El beso tan fuerte que el mozo le dio. Que el mozo le dio, que el mozo le dio. Hilando, hilando, el hilo rompió.
Polyester is made from oil, so recycling means we get more mileage from a precious resource. They convert polyester manufacturing waste on the left and plastic bottles into chip form. Pulses of hot air toss the chips, giving them hard shells. They go through a dryer to get rid of moisture that would weaken the final product. The shells keep them from sticking together, aiding the drying process. A worm screw moves the chips through heated pipes, which melt them into a thick liquid. This molten recycled polyester is now ready to be turned into yarn. It will be pressed through this die plate that looks a lot like a shower head. It's part of a device called the spin pack, which also includes a mesh filter, a metal distribution plate, and bits of shattered metal for extra filtration. It's important to screen out impurities that might compromise the recycled product. They screw the cap onto the spin pack and insert a metal connector piece. They preheat the pack so the polyester won't harden as it flows through it. Then they transfer it to one of the openings from which the liquid polyester flows. There are dozens of these openings, all capped by a spin pack. "68 tiny holes in each disc shape the recycled polyester into filaments. They cool and harden as they exit. Each one is 5 times finer than a single human hair. Some of it breaks during equipment stops and starts, and that goes into a big box to be recycled again. The rest converges and funnels into a guide, which bundles all the strands into one yarn. The yarn travels around rollers into a compartment where air buffets the yarn to entangle the filaments. This holds them together. A spool then racks up the yarn at a rate of over 200 kilometers an hour. An autonomous vehicle pulls up. The spools move into position and a long spindle emerges from the automated vehicle to collect them for more processing. They group a sample from every production run with strands of black yarn, which allows the lighter yarn to stand out. They fray both ends of the yarns with a razor, so they'll be easier to examine under a microscope. The technician projects the magnified image onto a screen and counts the number of filaments. At this point, the yarn is stiff, like dental floss, but that's about to change. This machinery pulls the polyester yarn over heated rubber rollers. The process stretches it and realigns the molecules. More equipment twists it, and then it's taken up by automated spools. Now this recycled polyester yarn is less like dental floss and more like wool. From plastic bottles and manufacturing waste to polyester yarn, this transformation has taken just a couple of weeks. This recycled yarn is now ready for the material world, making consumerism a less wasteful thing.
The three-point safety belt as we know it today, with the V-shape, was invented 50 years ago by a guy named Nils Bolin working for Volvo Cars in Sweden. And it was basically designed from a number of principles. Looking at real-world accidents, realizing that a lot of fatalities, injuries occurred, they needed to find a good way to restrain occupants better than what was available at that time. So the principles were, they found the work was to have a lap portion of the belt to keep the lower portion of the body restrained, and then the shoulder portion being over the chest to keep the upper body from moving in case of a crash. Also the low anchor points were important to keep a good belt fit during the crash event. And another very important principle as well was that it should be easy to use. So you should be able to put it on and also take it off just using one hand. It took quite some time actually to get it out there to the public. There was a lot of work done both to show with the crash tests the effectiveness of the technology. And it was firstly introduced as standard on Volvo cars in Sweden in '59, and it got here to the US in '63. So there was some time to convince both authorities and the general public as to the benefit of this technology.
Presently, about 83% of the U.S. population wears a seatbelt. That still leaves 17% that don't. But if everybody, all occupants in vehicles in the United States were to wear seatbelts, it's predicted that about 20,000 lives annually could be saved. So it's important that everybody does wear their seatbelt. Well, I think the important thing to realize is the seatbelt as it was originally designed still stands today as an incredible invention. And the basic design of the 3 points, the shoulder and the lap, hasn't changed. But what has changed is the technology as how the belt functions in a wreck. And Thomas can address that more.
Yeah, I mean, if you look at the seat I'm sitting in, it's actually 50 years old. And basically, just looking at it from the outside, this belt looks the same as the one that Dr. Moran here is sitting in, which is a modern one. But what's unique is when you look at it the inside, this is totally different. It has automatically adjustable heights. It's retractable. It has pre-tensioning function to reduce the slack in case of a crash, and load limiting functions. And with the sensors in the car knows what kind of situation it is, so it can adjust the functionality of the belt accordingly. So a lot has happened during the past 50 years, and there is more to come as well as we look forward. Both when it comes to how to better restrain occupants in vehicles with like 4-point belts and things like that, and also with the new technologies addressing how we can avoid collisions, which is constantly growing.
You can go to www.volvo.us.com. There's a lot of information on safety technology and safety features.
There you can find more information on how why it's important to use the safety belt, how to use it, and also how different groups of occupants from loving children to adults how they should use the restraints properly.
Today I'm going to show you what's inside your seatbelt mechanism and how it works to save your life in a crash. Now most modern vehicles come with a 3-point safety belt. That means there's an attachment up at the top of the B pillar, one down at the bottom there, and then of course your buckle in between the center console. Now the main part of the mechanism is hidden behind this B pillar cover here, so I'm going to remove this plastic trim. And down at the bottom here you can see this is the wire that goes to the explosive charge. This is the seatbelt mechanism and the seatbelt that leads up through it. And now I can remove the seat belt assembly from the vehicle. Now here I have the rear seat belt removed from the car. It would normally sit upright just like this. You can see here we've got the reel for the seat belt. Then on this side here we've got the torsional spring that helps it to retract back in its spot. And then on the side here we have this gear mechanism, and that's where all the magic happens to help it lock up. Now there are 4 main purposes to this internal mechanism, the first of which is your gravity sensor. Now it will sense if the vehicle is inclined this way or if it's decelerating this way, and it will actually lock the seat belt from expelling any more webbing material. However, if the vehicle is moving at a constant speed and the seat belts are relatively flat, it will allow seat belt to be pulled out. Now this cam will rotate with the retractor according to the gear ratio provided here, and when this cam reaches the point where this gravity ball is, it'll lock because I've got it in the slant position. Of course, if I bring it to a level position, it will unlock and I can use the seatbelt normally. Now the second purpose to this mechanism is to suddenly lock up if it senses a rapid deceleration or a tug on the belt, i.e. the vehicle is slowing down and the occupant is pulling on the seatbelt, it'll hold it in place. Now the third purpose of the seatbelt is to give you a little bit of slack so you can get this belt over your big fat belly and buckle it up before it'll start locking up again. So you can see that I've got a good amount of belt released here, and now the belt is starting to lock up. However, near the top here, it doesn't lock up when I tug on it. Now what initially allows the seat belt to move in and out is the position of the outside notch on this cam over here. Now of course the final purpose of this mechanism is to provide a complete stop when you pull out the seat belt. So if I pull out all of the seat belt here, you can see that it actually locks up when it reaches the end, so it doesn't pull it out of the reel. And you can see we have this light blue cam inside of here that rotates with the retractor, and then we have this cam on the outside here that will actually engage with this cam here when the seat belt has reached its maximum position. So you can see as I move the seat belt to its maximum position, click, that cam will click. It'll lock the seat belt from being extracted any further, and now in order to unlock it I have to keep retracting the seat belt until this cam moves all the way back around here, and then it will click this cam back into place just like that. And now the seatbelt is free to move back and forth. And of course we've got more spiders. Go away. Now I'm going to open up this mechanism to see what's inside and how it works. So I'm just going to pop off the top cover here and we can have a look inside. So this blue cam here serves 2 purposes. The first of which is to lock this tooth into the retractor. So this cam is going to come around here and click engage this tooth, and that's going to lock this green spline shaft here, which is attached to the retractor. Now the second purpose of this blue cam here is to disable and enable the gravity ball. Now this gravity ball will move up and down. Of course you need a little bit of slack in the beginning of the seat belt, so you don't want it to lock, so this cam here will move in and disable that gravity ball for this period of time. Once the retractor has expelled a certain amount of seat belt, this cam will move and allow this gravity ball to take over and lock the seat belt. So I'm just going to remove this gravity ball to show how it works. You can see here when the vehicle is decelerating, what's going to happen is that this tooth here is actually going to move upward, and that's going to engage with the splines on the shaft here to lock the retractor in place when the vehicle is rapidly decelerating. So now that we've got the 2 lock mechanisms as well as the gear inside of here off, I can remove this free spinning cam here. So inside of our blue cam here we have this little notch that actually engages this gear, which is on the inside of this gear over here. Now this is a little intricate because we've got this gear that rotates on the inside here, and that's got this green cam on it here that'll engage the slider. So this slider can move back and forth with the rotation of this gear, and this gear is connected to the cam through these 2 notches over here. Now we'll see why this slider can move back in a minute. So I'm going to remove this gear, this green cam, as well as this yellow slider. Of course, a lot of things go flying in this video. And with all these components removed, we still have the mechanism on the inside here that allows the seatbelt to lock when you pull it really quickly. Now you can see that this yellow slider had a little notch that when it moves back and forth inside of here, it activates a little tooth inside of there that's spring loaded. Now I'm going to remove this blue gear here. And then we have the green spline shaft. Now this here is the retractor tooth. You can see that there's about 10 degrees of free play inside of here. And this is basically locking and unlocking the mechanism on the inside that we're going to see next. Of course, you have the spring here that keeps the spring tension to keep this unlocked. So in this case, if it's moved in this direction, the retractor is unlocked and will allow you to pull your seatbelt. And if it's in this position here, the seatbelt is locked and you can't pull your seatbelt. Well, if you remember this slider that moved back and forth, it's got this tooth on it over here, and that engages and disengages the lock here. And that's to allow the retractor to unlock for the first few inches. Remember, it's controlled by this cam over here, so you can actually put this seatbelt around your big fat belly before it starts to lock up again. Now if I remove the retractor gear here, now inside of here we have two metal lockers that will lock this retractor shaft onto the housing spline here with these teeth. You can see that they operate by the principle of centrifugal force, i.e. if you're pulling the belt nice and slowly, these are actually going to stay where they are because they're actually attached to the spring through this gear that we saw earlier. Now what happens when you pull on the seatbelt really tight is that these will lock up. And that's because from centrifugal force, these will have a tendency to push outward as it's rotating this way. And that will cause these teeth to engage with the teeth in the housing and lock your seatbelt. Now in order to unlock the seatbelt, that's where this return spring comes in. It pushes these two cams together away from this gear and it will allow you to pull your seatbelt out. Now on this side here you have a giant torsional spring that's responsible for pulling back the seatbelt when you retract it. Alright, so I'm just going to pry up here on a screwdriver. Now this spring has a little notch where the retractor will retract in, and it's preloaded with a bunch of tension, and as you pull it out here it gets tighter and tighter, and of course as you retract it, it will retract back to its home position. Ooh, yeah. I told you a lot of things are going to go flying in this video, and you can see the spring is actually made up of, well, spring steel, it seems like, of course. Now, of course, the most important part of the seatbelt is the webbing itself. Now, these things have to be made really strong because it has to withstand the weight of a human during an impact in a collision. You can see it's sewn together with all these weave fibers here. In fact, it's so strong that I've actually used this to lift the engine out of the Corolla. Now, these are all the components that go into making the rear seatbelts on your car lock. Of course, the front seatbelts are a little bit different, so let's go have a look at those ones. So here we have the front seat belt removed from the vehicle. Now just like the rear seat belt, we do have your locking mechanism housed inside of here, and we've got the gravity mechanism that will sense if the car is decelerating. Now this one does not have a preset length where it starts locking, so it'll actually start locking from right at the bottom, unlike the rear seat belts, which had a different cam inside of here. Now also as you reach near the end of the reel, it just stops. There's no actual mechanical locker like how the rear ones had. Now of course on this side here we have your tension spring that's responsible for retracting the seat belts. Now what's different about this is that we have a pre-tensioner on this seatbelt. Now how a pre-tensioner works is we've got an explosive charge on the inside here, and during a collision this explosive charge is going to fire off just like your airbags. Now what that'll do is if you've got any slack inside of your seatbelt, it's going to tension that up so it goes nice and firm against your body and it holds you against smacking your face from the dashboard. Now because it is a little bit dangerous for me to start taking this apart with this explosive attached, I'm going to fire off this explosive. There's two contacts here that you apply 12 volts to, and I'm going to show you how the pre-tensioner works. So you can see this is my setup. I've got the seat belt with a little bit of a loop secured by a brick over there, and I've got a brick on top of the seat belt and tensioner over here, and of course I've got my wires that I'm going to take out to my battery. 3, 2, 1. There you go. Alright, so here we have take 2, the passenger side belt. I've got a lot more tension in the seat belt so we can see if it's going to retract. So I'm just going to put my brother's old toothbrush here just to see what it's going to do. 3, 2, 1. Alright, so you can see here that was quite a lot of force, and we have a broken toothbrush. And we have the other side of the toothbrush here. My brother's not going to be too happy. Okay, so we have 2 exploded seat belt pre-tensioners and 1 broken toothbrush later. And you can see that the driver's side belt here is all tangled up and wind up, and it's completely locked. On the passenger side here, it's kind of locked. It's still messed up. It doesn't retract very well. You've got your pre-tensioner here, which I can now magically screw off. And once you screw that off, you can see that there's this piston inside of here that actually moved from this position to this position during the explosion. And then you've got these 2 cables here. Now I'm going to pop off these plastic covers to see what's inside. Of course, you have your spring tensioner inside of here to retract the seat belt. So inside of here there's 3 Torx bolts that I'm going to remove next. And then I can remove this top cover, and then I can remove the pre-tensioner assembly. So we can see inside of this pre-tensioner we have this cable that's attached to the piston for the explosive. Now what happens is when this explodes, this is going to explode in this direction over here, and it's going to tug on this cable. Now when it tugs on this cable here, it's going to tend to rotate this ring around this shaft inside of here. Now this ring is connected to this shaft here through these key notches on the side here. Now before the pre-tensioner blows, this wire is actually wound up inside of here. When the pre-tensioner blows, it'll actually pull on this wire, and that'll cause this to rotate, which will in turn turn the shaft, which will retract the seat buckle inside of here, pulling it back against your body. Now of course all of this happens within a few milliseconds of you colliding with another vehicle. It's usually triggered by the airbag system. Now, of course this is going to lock up and become useless once you crash, so you will have to replace this if you intend to put the vehicle back on the road. Ooh, that was a lot of force. Well, there you have it. These are all the components that go into making your seat belts work to keep you safe in the event of a collision. Make sure you subscribe if you want to see more videos just like this one.